In most of the cases that we've talked about so far, we've only dealt with series that have positive terms. Now, what about expressions that have both positive and negative terms? So one of them is called an alternating series, and we're going to think about what's a way we can figure out whether an alternating series converges or not. Now, this one that you see up here is an alternating series. Notice that all that means is that the signs on the numbers alternate from positive to negative or vice versa. But because this is a geometric series we can do whether the terms are positive or negative. We know that r is negative 1/2, absolute value is still less than 1/2, so we can still say that this converges. Now, what about series that are not a geometric series? In that scenario, in order for a series to converge, two things have to happen. First of all, the limit of the general term has to go to 0. So don't look at the -1 part, but just if you look at that term without the alternating sign, does that limit go to 0? So that means the numbers are getting smaller. And the second condition is that the a sub n plus first term has to be less than the a sub nth term. Again, all this is saying is that the next term over is smaller than the previous term. You can think of it this way, or another way you can think about it in terms of words is that you have an alternating series and the numbers are decreasing magnitude 0. Or if you look at just the absolute value of the numbers, they're getting smaller to 0. That's another way you can phrase it. Okay, so let's go ahead and look at a couple examples and see what happens. So this is an alternating series, and this is what gives it away. You have either -1 to the n, you can have -1 to the n plus 1, you could have a -1 to the n minus 1. That's going to make your signs alternate. This is not a geometric series, so we have to use our alternating series test. So first thing is check, is the limit of the general term, so look at the general term without the -1, does it go to 0? Yes, this limit is 0. 1 over infinity is 0. The next thing you want to check is that is the next term over, is the n plus first term less than a sub n? So create the n plus first term. So is 1 over n plus 1 less than 1 over n? Yes, this is always true, right? When you add a number on the bottom, it makes the bottom bigger, but the whole fraction gets smaller and smaller. So both conditions are true, so you would say it converges. So you can either show the two conditions, and that would be your work, or you can actually write out that the absolute value of the terms go to 0. So either way is fine of showing your work. Okay, number 2, same thing. So again, this is an alternating series. If you want to write out a couple terms to see what happens, that's fine, or I know because of this it's alternating. So let's go ahead and check our conditions. I always check the limit condition first. So is it true that if you take the limit of the general term, is this equal to 0? No, it's not. So I can say that this alternating series diverges by the alternating series test, and we can use AST in our work to show that. Since this condition is not met, it doesn't matter if the second condition is met or not. Okay, let's take a look at the next one. And some of these series, there may be more than one test you can use, and you want to use the test that's easier. Okay, the easiest way to do this is if you recognize right away that this is a geometric series. You have two things raised to the nth power. This is just a constant. I notice that your r is actually -1/2. The absolute value of r is less than 1, so we can say that it converges because it's a geometric series. So this is probably the easiest way to do this one. Now, if you don't recognize it's a geometric series, but you do realize that it is an alternating series, you can use the alternating series test. You would show me, okay, is it true that the limit of the general term without the alternating sign, does that go to 0? Yes. And is it true that the n plus first term is less than the nth term? Yes. Both conditions are true, so you would say it converges by alternating series test. Or again, you can just write out absolute value of terms go to 0 if you recognize that. Okay, last one, again, we're going to use the alternating series test here. This is not a geometric. So let's start with the limit of the general term. Is that going to 0? No, it's 1, so we say it diverges.